Hello there, I'm Caleb Hangeveld, a grade 12 STEM student, and I'm here to talk about my grade 12 capstone beta. For this capstone beta project, I made a system that records a video each time motion is detected by the motion sensor and sends an email notification that allows you to access the videos. The original use case was to monitor one of the intersections in my neighborhood to get an approximate value of how many cars passed through at ridiculously high speeds per day. But this could also be used inside to watch over a door or room, or outside one's house to watch somebody's backyard, and record anybody that goes through. The Raspberry Pi is a small, low-cost computer that runs the code that tells everything else what to do. The PIR motion sensors for detecting motion at the intersection. The Raspberry Pi camera is for recording videos at the intersection. The power supply is for keeping everything on, and the containers for protecting the components from the elements. PIR stands for passive infrared and detects motion by monitoring changes in the infrared radiation of its surroundings. Infrared radiation is part of the electromagnetic spectrum, detected by humans as heat and emitted by everything above absolute zero, which is equal to negative 273.15 degrees Celsius. The PIR sensor has two slots, both made of an infrared sensitive material. When nothing moves past it, both slots detect the same background infrared of its surroundings, but when something moves past it, it passes by one slot first and creates an infrared difference between the slots, thus detecting motion. The lenses over the sensor are actually made of several Fresnel lenses to condense light to increase range, and to split two big sensing areas into many small sensing areas. My sensor has a maximum range of 6 meters and a maximum view of 110 by 70 degrees. To limit its view to the intersection, I used a PVC pipe to block infrared coming from anywhere besides the intersection. When it detects motion, the Raspberry Pi camera starts a 5-second recording. Because the camera takes time to warm up and turn on, something moving very fast and/or perpendicular to the camera might be able to pass it before it starts recording, but it usually warms up fast enough to catch whatever triggered the motion sensor. The recording is saved to the Raspberry Pi, which sends an email that has something called an IP address. So long as both my laptop and the Raspberry Pi are connected to a Wi-Fi network, this address can be used with an app called VNC Viewer to basically run the Raspberry Pi from my laptop, thus allowing me to access the videos. This project helped me exercise my coding skills and taught me more about how to use the different features of a Raspberry Pi, such as configuring it to re-enable use of my camera. Learning about coding and Raspberry Pi would likely be helpful for any computer-related career. If I was to change something about how I did this project, I would have started making plans for building my container and looked more into the warm-up time issue in the first week, rather than partially making the container's design up as I went along and having little time to deal with the warm-up time issue in the second and third week. I would have also put the system up sooner so that I could collect data and troubleshoot. If I were to continue this project, I would try to have the camera use object recognition to only record when cars go past, as opposed to bikes or people. That's it. Thank you for watching.